Now, before the end of this unit, 2 words of caution. The first one is that the border between NP completeness and polynomial time can sometimes be very thin. I already mentioned to you that, for example, 3-sat, so where you just have 3 variables in each clause, is NP complete, but 2-sat, where you just have 2 variables, is solvable in polynomial time. And there are many other cases like that. But of course, this is good news, because if your problem turns out to be just as hard to solve as 2-sat, you actually have a polynomial time algorithm for it, although it might initially have seemed a bit harder. Or sometimes, even if your original problem possibly is as hard as 3-sat, maybe you can look at a slightly different problem that becomes polynomial time solvable. Because oftentimes, there's many different ways to frame the practical problem that you're trying to solve, so sometimes you're lucky there. The second thing is an actual word of caution, because this border here can sometimes be so fragile. It's very important to be precise in your NP completeness proofs, because sometimes making just a little mistake in an NP completeness proof can invalidate this whole proof, and of course we don't want that. Now it's time once more to congratulate you. You now know what NP completeness means and how you can show NP completeness. And actually not many people can do that. Very few people know precisely what NP completeness means, and also they're not capable of showing NP completeness. In the next unit, we're going to take you even one step further. We're going to show you countermeasures against NP completeness. Because even most people that understand what NP completeness means and that can also show NP completeness actually tend to give up once they have shown their problem to be NP complete. But that's actually not necessary, because there are many, many techniques which you can use to attack even NP-complete problems. So what should you do when you want to solve a problem and show that it is NP-complete? Should you carefully check your proof? Should you have somebody else carefully check your proof? Should you give up? Should you maybe try to think about ways of modifying your problem so that it could not be NP-complete? Or should you try to use the techniques that you're about to learn in the next units of this course?